So looking at this problem again, let's look. From what height in feet was the ball dropped? We figured out that you make the time 0, and now you know the height. So over here, it's height based on time. As the time changes, you get a different height. So we figured out that the height, right, if you move this over, you'll find out when this becomes 0. The height has to come down to 0. That's what you're wanting to know. So you say 0 equals 16.1 t squared plus 150. So now we have to move this over. And so when you move it over, you add 16 here and you add 16t squared there, right? So now you have 16 equals 150. So you divide by 150 and you get 16. All right. This is good exercise, right? 16.1 divided, 150 divided by 16.1. You move the decimal, so 160. Probably about 9. Let's see what happens if I do 9. So I put a 9 here. That becomes a 4. Okay, put a 9 here, and this has to move over. 4, put a 5. So this would be 1449. So this is 51. Bring down the 0. I guess we need about 3. Okay, so it's about 9.3. That's going to be t squared equals 9.3. Well, it looks like in about 3 seconds. So the way to check it is you put in 4, and this would be 16 times 16, maybe 256. That's too big, right? This would be like negative 100, because it's 256, subtract 15, 150. Yeah, it's about negative 100. It's gone into the ground. So it's probably closer to 3. So if we put in the 3, so that becomes 9. 9 times 16, right, is 144. Yeah, 144. So we have 150 minus 144. About 6. So at 3 seconds, it's 6 feet above the ground, right? So it's like 1 second, 2 second, 3 second. Boom, it's about to hit. So it's going to be about 3 point something. This is what I have a problem with these online people. You can be so close, like, how many seconds rounded to the nearest hundredth did it? I mean, who does this? Who cares if it's 3.1, 3.2? It's around 3 and it's not 4. So they're going to, you got to do this exactly. I'm finished with this one.